Hey everyone, good morning. I am Priyanshi Agrawal and welcome back to my YouTube channel. Now we are going to solve today's Leetcode daily challenge, which is design a number container system. Okay, so let's see what is this question and how we can solve it. So in this question, you have to design a number container system that can do the following operations: insert or replace a number at a given index in the system, and return the smallest index of the given number in the system. Okay, and in this way we need to implement the number containers class, in which the number containers constructor will initializes the number container system, and we have to implement this change function, which contains parameters index and number, which should fill the container at index with the number. If there is already a number at that index, replace it. It means we need to create the track of a corresponding index and its number which is stored at that index, right? So how we can keep this track? Either we can store it in an array or in a map, right? And we need to implement a find function which contains number as parameter and returns the smallest index of the given number, or -1 if there is no index that is fed by number in the system. Okay, so for a single number can be stored at multiple indexes, right? And for a number we need to return the smallest index, or -1 if that number is not stored till now. So if we need to keep the track of all the indexes at which a particular number is present, then what kind of data structure we might need to store these indexes? Either we can store them in a set, map, or a priority queue. Why priority queue? Because we need to return the smallest index. Okay, so we will see that which data structure we will use, but these can be the possible data structures which we can use here. Okay, so let's see first example, in which we have to find 10 and then change, find. Okay, so let's see. So first we need to find 10. Okay, so can you see 10 till now? No. So what we will do? It will simply return -1, right? Okay, so now the next operation is change index to value 10. It means we need to store 10 at index 2. Okay, now change 1 to 10. Okay, so now change 1 to 10. Again, this was already changed before. Now change 3 to 10. So this was our previous array, or whatever we can say. Now we will need to change index 3 to 10. Okay, so let me tell you one thing, that we will create it as a map. Why? Because we are storing all the indexes, right? So the size of this array will become index. Okay, and from the constraints you can see the index can go up to 10 to the power 9. So we cannot create a vector of 10 to the power 9. That's why we will create this as a map. So now we are confirmed with our one data structure. Okay, let's see this example further. So this was already updated. Now change 5 to 10. Okay, cool. Now we need to find 10. Okay, and what we have given that? We need to return the smallest index, right? Okay, so 10 is stored at 1, 2, 3 and 5, but we need to return the smallest index. So what we will return? Return -1. Sorry, return 1, right? We will return 1. And this will remain as it is. And now we need to change 1 by 20. Okay, so we will update this value to 20, 10 and 10. Now we need to find 10. So see here, we have already updated the index 1 with 20 value. Now for the value 10, the smallest index is 2. So it will simply return 2 and our map will remain as it is, right? So you can see what we have our answer is. -1, null, this will be null, this will be null, 1, null and 2. Okay, so see, -1, null, 1, null and 2. Okay, so this is the thing which we need to do, but how we can do it? Like, okay, we have created this map. Okay, but how we will return the smallest index of our number? Okay, so let's say we will create another map which will store number to all the indexes, integer comma set. Okay, so ever we have predicted three data structures and we have picked only set. Why? Because see, we don't need to store any frequencies, we just need to store all the indexes of that number. Okay, so map is discarded. And why q is discarded? Because we need to find out the minimum element, and then we also need to update the element. Let's say in this case, when we are updating the existing index 1 with 10, so we will need to remove that index. Let's say 10 will be storing 1, 2, 3 and 5, right? And then we are asked to update index 1 with 20. So we will, let's say instead of 1 we were asked to update index 3 with 20, right? So what we will need to do, we will need to pop out or iterate in this complete queue and then remove this 3 and then again need to insert all these elements. So this will create a lot of chaos. That's why we have also discarded queue and we have choose the set. Okay, so let's start iterating on this example once more, so that we see how we can incorporate this set, this map to solve this question. Okay, so we are asked to find 10. Okay, so till now there is nothing in our this map as well and this map as well. Okay, now we are asked to change 2 to 10. So we have updated in this map. Okay, and we will also update in this map. Now 10 is storing 2. Cool. Now we are asked to change 1 to 10. Okay, we have updated this map and now 1 to 2. And this is an ordered set, so that's why it will be storing all the numbers in ascending order, in the sorted order. Now we are asked to change index 3 to 10, so we have changed this map and then this map will also get updated, right? Now we are asked to change 5 to 10, so now 10 will also store the index 5. Cool. Now we are asked to return the smallest index corresponding to number 10. Okay, so we cannot find the smallest index from this map, right? Because this is just storing the index in number mappings. So we will reach to this map and we find that number for which we need to return the smallest index, and we return the first value as this is storing all the values in the sorted order. Cool, so we can return 1 from here. Now again we are asked to change 1 to 20. Okay, so what we will do? We will check if 1 already exists in this map. It means it has already been updated earlier, right? So if index 1 exists in this index to num map, it means it has been already updated earlier with some value. So what we will do? We will go to our num to index mapping and search for that number and remove that to 1 index from the num2 index mapping, right? And we will simply update this index 1 with 20 value in this map and 20 with 1 in this map too. Again we are asked to find the smallest index of 10, so we will return the smallest index of 10 from here and it will return 2, right? So the key thing to pay attention is that we need to check if that index has already been updated in this index to num mapping. It means it is already storing some value earlier and we are replacing it. So we also need to remove that index from our num to index mapping, right? Because let's suppose we are removing the one element here. Let's say if it is not the smallest element to its smallest index, let's say as I have told you, we are asked to remove update 3 by 20. So we need to remove 3. It doesn't matter whether it is the smallest index or not. If that index has already been updated earlier, we need to remove that index from our num2 index mapping, right? Okay, so let's see its code as well. So see here we have created two maps, num2 index and index to num. Okay, so in the change, we will check if index to num is already storing some value at that index. It means we are replacing that index value. So what we will do? We will store the number which is stored earlier at that index. Let's say in this case 10 was stored earlier, and we will go to our num to index mapping and erase that index from our map. Let's say here we were storing 1, 2, 3 and 5 and our index is 1, so we will erase this one from our num to index mapping. And let's say if instead of 1, 2, 3 and 5 here was only 1 and we are removing it, now it became empty, so we will also remove this complete key from our index to num mapping, and we will simply update index to num, index with number, and insert that index in our num to index map. Okay, so let's see once, like for erasing in an ordered set, it will also take log of n complexity, and this is we are just erasing in a map, so it will take big O of 1, and this will also take big O of 1, and we are inserting in an ordered map, so that's why this will again take big O of log n, right? And for finding, we will check if that number exists in our num to index map. So what we will do, we will access that complete set and we will return the first index which is stored in that set, and first index will give the smallest index. If that number doesn't exist in our map, it means we have not stored it till now, and we will simply return -1. And the complexity of this will be big O of 1, as we are just accessing the first smallest index, right? So what are the overall time and space complexities? The time complexity for find function will be big O of log n, and change function will be big O of n, and space complexity will also be big O of n, as it can store up to maximum of n numbers, right? So this was all for this question. I hope you get it, but if you still have any doubts, then you can post in the comment section. I will surely try to answer them. Till then, bye guys, see you in the next video.